Is this on? Okay, okay. You guys can hear me all right? Okay. Well, I can't see you, so hopefully things are going okay. So like Bob said, I'm a data scientist working for Stitch Fix, which is a company that you probably haven't heard of if you're living in Europe, but you might have heard of if you live in Silicon Valley. The way that this talk is going to go is I'm going to explain to you what Stitch Fix is. I'm going to talk to you about how it works as a business. I'll explain to you the kinds of unstructured text data that we have, and then try and tell you some of the techniques that we've attempted to use to better fulfill client requests using this text data. Okay, so Stitch Fix is sort of like an online subscription service. It operates on something that is sort of like a subscription model. Basically, it starts out, you as the client would fill out your style profile. You would explain to us what kinds of things you like or do not like about your sort of personal fashion tastes. Some of those include things like your style. Some of them include things much more like latent variables, like I like to wear boho type things. Then all of this gets kind of ingested by algorithms, and we basically present an expert stylist with a ranked list of what we think that you as the client will like. She will select 5 items to send to you, and then once you receive those 5 items, you can either keep any or all the way down to none of them, and then send back the things you don't like. Oh my. All right, so when I say that we're filling out a style profile, that includes things like how you want your clothes to fit, whether you prefer pants, jeans, or skirts. Most of our clients are women, but we do have men's, women's, plus and a whole bunch of other different sizes and shapes. When you get 5 items, those items are not something that you as the consumer basically get to select. You do not know exactly what the items are we have in inventory as our clients, but our stylists do get to see a filtered set of those of that inventory. So in this particular example, there's a set of bracelets, a dress, a top, some jeans, and a kimono, which is sort of like a sweater, but not really. And then once you actually receive that, you get to pick as many of those items as you like. This inventory, like I said, is sort of hidden to you as the client. That's the kind of thing that makes Stitch Fix sort of magical, which is that what we're actually using are algorithms to determine the items that clients ultimately get sent. But that sort of whole thing is uncertain, right? Whatever we happen to have in the warehouse that day, whatever our clients happen to say that they like that day, whether we have things that are in your size or not, all depends, all of that influences what the stylist ultimately sees. So in this intervening little middle arrow, that's kind of where a lot of the human-in-the-loop computation happens for us. And our stylists are responsible for ingesting almost all of our unstructured data. So that means understanding what the client has asked for, understanding really what her stylistic preferences are. The way that we present information to the stylist, can always be better in order to help them find the things that we want our clients to actually enjoy. And then, kind of at the very end, there's this whole subjective experience that the client has of the items themselves. So is this something that I would actually wear or not? So there's, on the side of one of the kind of things that distinguishes Stitch Fix from a bunch of other retailers like this is that we do use machine learning at every single step of the process. So we're trying to figure out, what kind of web page should you see when you land on the website? What are the things, how much should we weigh whether you want boho clothes versus things for work? And we can also kind of predict a whole bunch of different variables. But at the moment, what we're really struggling with is using all of what clients actually say about our inventory in this process. So we can build a ranked list based on your stylistic preferences, but we can't necessarily change the ranking of those things based on the actual items that you've requested, for example. So if you say, hey, I'm looking for a printed blouse and a set of wide leg trousers, you actually might not necessarily get those things. And so we would like to be able to say, okay, those should be higher in the list than what they might currently be. So that human curation part is something that like we're actually able to leverage pretty heavily, and I think that you'll kind of eventually see that this is one of the reasons why we're able to do the kind of natural language processing that we are. There are a whole bunch of different text data sources in this whole process. At the very beginning of the process, when clients are filling out their style profile, they talk about themselves. So like you can say, I'm a mom living in Chicago, and I tend to dress pretty conservatively for work, but on weekends I can wear whatever. Then you can talk about like the things you want for this particular shipment. So you could say, I'm actually going to a trip to Jamaica, and I really want a maxi dress and some cute sandals. Kind of in the intermediate point, the stylist will have read both of those two things, and then hopefully will have selected something for you that is like what you asked. So in the middle, there's a personalized stylist note, and she can explain the items that she selected for you, in addition to why you should like those items, and whether or not, like for example, she fulfilled your request. So in certain cases, maybe we don't even have the inventory that would fulfill that request. Like if you requested a maxi dress in the middle of winter from, you know, and if you live in Alaska, there might not be something that we can send to you. Then at the end, you know, clients can fill out a sort of sentiment about the entire experience. So you guys really nailed my style, or I don't understand why you guys sent any of these items to me. Then there's the option for filling out individualized item feedback. So let's say that you did end up sent a maxi dress or something like that, and you're just really not into it. You can say, okay, this was totally not my style. Or you can say, I love the little details on the collar or something like that. And then maybe if it was the wrong size or it had some kind of damage or something, you can contact customer experience, customer service, and they'll help kind of help you find the right item and solve some problems for you. The things that I'm going to be focusing on are the request data, so things that our clients actually ask for, as well as the item feedback, so the things that clients say about our inventory when they keep the item or when they don't keep the item. And I've already used a couple of fashion terms that probably are somewhat unfamiliar to the audience here. And I think that there's kind of a really interesting analogy to natural language processing and like non-native language comprehension, or even native language comprehension, where you don't have this like sort of domain-specific knowledge of specific terms. So behind me, on the far left is a party dress. In the middle are some penny loafers, and on the left are some gladiator sandals. On the right are some gladiator sandals. All of these things are like reasonably niche terms that may not be totally obvious what they refer to. So for example, I have no idea why penny loafers are called penny loafers, but it just refers to this particular class of shoe. Likewise, a party dress is fairly transparent, but you don't necessarily know what is appropriate for any one given party. So the kinds of dresses that might occupy that space are very varied and may look totally different from one person to the next. And gladiator sandals are something that sort of makes sense in retrospect, like having seen them, it's like, okay, yeah, a Russell Crowe would have totally worn those in the movie Gladiator, but in fact, you know, it isn't really totally clear how they should look, and they're sort of varied in the way that they manifest. Stylists, when they see requests for party dresses and penny loafers and gladiator sandals, have to comb through all of our inventory to try and find whatever matches those requests. And we would ideally like try and make this process easier. So hopefully we can say, okay, well, we can highlight these items, or we can change the ranking of the list that stylists ultimately see and say, these are things that the client wants. The problem here is that I've made this huge assumption that we can find out what those things are, that we can actually go through those lists and say, okay, well, these are the concepts that are really important and that we can fulfill. So one question we can ask even is like, what kind of concepts should we be learning in order to actually fulfill clients' requests? And some of these are like sort of abstract concepts, and some of them are fairly familiar. So one of the things that seems to be trending these days are ruffles, which are like this pink sort of shirt up here. Ruffles are a fairly common trending item, and they're sort of commonly requested. In the middle, there's another thing called a cold shoulder top, which has to do with like these cutouts on the shoulder it's cold. It sort of makes sense, but it's not immediately obvious if somebody just requested it from you to go to the store and find a cold shoulder top. Same thing, clients will sometimes ask for things like lavender, colored items, but maybe we want to also show them purple items and know that they're sort of similar to each other. And same thing, party dress is a vague concept, but hopefully we can find one that suits the client. One of the things that occurred to me when I was building these slides is that even sort of regional knowledge, things like I'm looking for some summer clothing for Arizona weather, means something very different if you don't know much about Arizona. So some of our stylists are in Pennsylvania, some of our stylists live in Dallas. And these things all across the US is a very varied country weather-wise, and so if you don't know how hot it is in Arizona, you might not actually be able to find the right thing. And I realized that these are all in, this is all in Fahrenheit, so if you want, you can kind of just imagine that all of these temperatures are in about like 40 to 44 degrees Fahrenheit. It's pretty hot almost all year round. So ideally, you know, like a stylist would pick items that are more like shorts instead of pants, or cotton instead of polyester. Lots of different like sort of variables to consider there. So again, like I kind of want to emphasize that we should be able to learn these concepts from the data that we have, at least as a first pass, because of the fact that our data are so domain specific. So, you know, even phrases like gladiator sandals, for example, are not going to be in Wikipedia. They might be mentioned somewhere in the sandals page on Wikipedia, but they're not actually going to be the sort of thing that you would immediately Google for. So we're going to try and use our internal data sources to identify these concepts. Then we're going to try and figure out how to fulfill client requests, which it turns out is a little bit harder than you might expect. And I'm going to frame this as an information retrieval task, but it can actually be framed in a couple of different ways. So information retrieval, as you might be familiar with, is a lot of like what Google does when you go and search for something. So you say, I'm looking for gladiator sandals, or maybe I'm looking for the Wikipedia page on gladiator sandals. And what you'll see is that on the very top, Wikipedia does mention that gladiator sandals are a concept in the world, but it doesn't really explain how it's different or that it is its entirely own concept. Another sort of issue with searching for gladiator sandals is you might end up getting the wiki page for the movie Gladiator, which is a totally different and irrelevant example. Then there's Vogue apparently wrote an article a couple years ago suggesting that this kind of suggests that gladiator sandals are out, but maybe it's the case that Vogue knows more about gladiator sandals than anybody else. And basically, there's a lot of different sources here, some of which are relevant, some of which are irrelevant. And we want to find some kind of document to serve to our clients in response to some kind of query is the idea. So when we say wiki gladiator sandals, we're actually saying, gladiator sandals, stylist, please send them to me. And then hopefully showing gladiator sandals of some kind, which we can conceptualize as a sort of document. So in this case, like we have a couple of different variables. There's a vocabulary, which is whatever these concepts are. So it's all of the different words that all of our clients have ever used. There's a query, which is a subset of all of that vocabulary that contains any number of words from those. So it could be gladiator sandals and please out of the whole vocabulary of the English language. And the documents can be any of the feedback that we get from all of the items that we have. So we know exactly everything that everyone's ever said about this item when they've sent it to us or back, or when they've bought it. So we want to ideally rank these documents by their relevance to this query. So we're going to basically measure the similarity between the query and the documents themselves. And that similarity function I'm choosing to leave somewhat agnostic at this point, but you can imagine that if you're familiar with information retrieval, this could be something like TF-IDF, or it could be something like a little bit more like magic on the back end, like what Google does, involving a whole bunch of vector math and neural networks and all of that. So I'm going to start again with this assumption that items are documents. So these are going to be things that we actually carry in inventory. So that pair of gladiator sandals or this sort of moto jacket is going to be something that we can collect statistics on based on what our clients say. So this particular jacket is gray and it has a bunch of zippers. Lots of clients, you know, think that it's cute. It happens to belong to the category moto jacket, so we're going to assume that clients have said moto and jacket a lot about it. And we're just going to count up all the times that we see every word with every item, and then we're going to rank them. We're going to rank the meaningfulness of the words basically by like the number of items that word doesn't occur with. So the more infrequent that item is, or rather the more infrequent a particular term is, like moto, the more important that word should be for this item. Because clients will often say, like, I loved it, I hate it, etc. That'll occur for almost all of the reviews that we get for every single item. Those are not really relevant for information retrieval purposes. We're trying to find the sort of best matching informative words. Then we're going to like start with the other assumption, which is that requests are like queries. So this is a bit of a tenuous assumption in some ways because it's like it kind of assumes that queries are like requests as well. If we're trying to find the right document, then that means that the words that are in a request, so like gladiator sandals please, that those are the terms that we actually want to focus on. But more broadly, a request might even be something more vague. It could be like, I'm looking for gladiator sandals and maybe a party dress, but whatever you feel like is good will work for me, right? So requests are long and unstructured in the way that typical search engine queries are not. And this is partly because in a typical search engine, you've learned to Google for things, right? So we actually understand the constraints of search engines. And the more and more we use those, the more we understand that we can't ask for things in a certain way. And some of you guys probably remember in the beginning of the internet, right? You used to not be able to Google for questions. So you couldn't say, like, what is the capital of the United States, right? And now Google will actually show you the right answer. So what we've been having to do as a company is have our stylists handle these queries, right? So they are the magic kind of going on, and we want to like simulate this. So in order to actually treat this as an information retrieval task, we have to redefine these documents, which means to say that vocabulary that I pointed out earlier, we actually have to specify. And so there are two obvious sources of data, like I alluded to earlier. There's the client feedback on the items. So these are the things that clients say when they say purchase an item for us. Like, it was really great. I love moto jackets in general. Or it could come from the request themselves. So maybe a client said, I'm looking for a moto jacket. And we assume that a stylist has honored that request somehow. And then we can still learn those properties. But that might also be, as you'll see, maybe not the best way to do this. But we're going to try and learn it anyway. So our feedback data is actually really fascinating. First of all, in terms of a data source, it has a one-to-one relationship with an item and the review. So we know, just like kind of when you see a review on Yelp, that this is about that restaurant, this is about that item. There's no doubt whatsoever that this is the terms associated with an item in a review are going to be about that item. So in this case, I went and did some digging. This particular item has an asymmetrical zipper. It's a fun jacket, a moto jacket, a nice jacket. It's edgy. It has a zipper detail. But as you might imagine, not all of these terms are going to be things that people actually ask for. So it turns out that if you try and figure out the items, the terms that are in common between what clients request and what clients actually say when they buy an item, they're not going to talk about certain terms. So clients, it turns out, don't really ask for asymmetrical zippers. They don't ask for unzipped items. They don't ask for unzipped issues or whatever the term is being used for there. They don't really specify things in terms of zipper details. They'll say, maybe I'm looking for something with a cute zipper or something along those lines. And similarly, the term great jacket really might describe this item, but it doesn't ever show up in request notes. So clients will not say they are looking for a great jacket. They'll say, I'm looking for a cute jacket or a nice jacket. Great jackets are things that people say when they actually like the item. So like I suggested, if we're trying to fulfill requests based on like the relevance, if the data actually don't reflect, if the requests don't reflect the data that we're training our documents on, and we don't have, sort of like click-through rates like Google does, it's a little bit hard to figure out whether we've made the right decision or not. So what we actually have to do is think about how requests differ from these representations. So one other possibility is that we could use request data directly. We could pretend that there's no noise in requests and that everything about a request is relevant to an item that our stylists and our clients. But I'll tell you that so just because feedback data is insufficient, there are going to be some problems with using request nodes directly. So even though they're relevant for search, so in this case, this client has said, I'm hoping for another black blazer in this fix, only one of these items is actually the same as what the client asked for. So you'll see that there's a gray jacket, some jeans, some penny loafers, and a purple top. But none of those items were actually asked for. The client only said that she's looking for a black blazer. And there's only one black blazer in this fix, which means that if we're just trying to count up all of the times that we see a bunch of different words with an item, we're going to end up learning that this purple top and these jeans and these penny loafers are sort of like a black blazer, which is not exactly the representation we want to learn. So we have to be able to get around this a little bit. We want to be able to extract out the most relevant bits. So we want to say, okay, well, there's only one item in this request that was relevant, or that was relevant to this particular request. So this black blazer is the only item we should focus on. So we're going to basically try and identify the signal that's in these requests beyond simple co-occurrences. And I'll walk you through the methods that we actually use there, with the explicit goal of also being flexible. So if a client says something like black blazer, we want to be able to say, okay, well, maybe other black sort of jackets or other kinds of colored blazers, like maybe a navy blazer, would be okay. And this is because requests and words, the meanings of words, are vague. So we might want to consider the case that if a client asks for lavender or asks for black, that we want to show purple or navy. If a client says that she's looking for something comfy, we want to show something comfortable as well, right? Just because those two things are basically synonyms. So Google is definitely capable of doing this. Why not us? We want to be able to do some sort of fuzzy matching. So instead of matching every single word in a request, we're actually just going to try and match some of the words to some of the items. And so even if there are mistakes or misspellings or slight changes in language, we're going to be able to find the right thing for a client. And in order to do this, you'll have to humor me. I am not throwing a neural network at this, but the algorithm that I did use is sort of like word2vec, in which we're able to learn the meanings of items and words at the same time. This means that what we're basically going to be able to say is that slow is like slower and slower is like slowest, in the same way that fast is like faster and faster is like fastest. Basically by looking at the context where words occur, and in the same way looking at the items where words occur, we can sort of piece out the parts that refer to that item in particular. So we're going to be learning a whole bunch of vectors, the idea being that a word is a function of its parts because of the things that it occurs with. So if we talk about dachshunds, so like these cute little, this little black and white, black and brown puppy on the left, or poodles, the dog on the other side, we want to be able to say, okay, well, we talk about dachshunds and poodles in very particular ways, right? So because they're particular breeds, we're not just talking about them like they're individual dogs. It turns out that toy poodles and toy dachshunds are a thing. So if you want a very tiny dachshund or a very tiny poodle, those are going to be more similar to each other than the concept of a toy Great Dane, which is, I think, as far as anybody knows, sort of physically impossible, and maybe a contradiction. So we want to say that dachshunds and poodles are similar, right? So like we'll treat those ultimately as vectors. So there's some dachshund vector and there's some poodle vector. And the similarity between those two things is basically what we're trying to identify. The way that word2vec works is by a pretty straightforward classifier, although using a whole bunch of other sort of like neural network neuromancy. What we're going to basically try and say is we're using the input, which is everything else in a sentence. So this is a, and then we're going to try and predict the word sentence about words and with additional input. So if we have this input context, we're trying to predict the missing word, right? And as the algorithm learns over and over, it's basically these things all co-occur with sentence when sentence is missing. And so we want to be able to say dachshunds and poodles are similar, right? So we want to be able to say that these vectors in space should represent similar meanings. And there's another mechanism that we have for that, for dachshunds and poodles, which is that if we're going to be saying that this is a sentence about dogs, we're going to try and predict the word dog and the entity, which is this cute little dachshund picture. Well, I think he's cute anyway. So we're going to try and predict the missing word and the missing concept, where basically we're allowed to compare individual words to items because they're in the same vector space. And words and concepts that are similar to each other will occur in similar environments and will therefore be similar, will have similar high scoring values in some vector space. So I'm going to kind of point out that we have to do a whole bunch of different evaluation here. So like, how do we know that we've learned the right thing? So we're basically just going to do a whole bunch of sanity checks looking at the vectors that we have. So if I'm going to use the term wedding, what I want to be able to say is that these dresses are all relevant to weddings, at least in the United States among our particular set of clients with our particular constraints on inventory. Turns out that when clients ask for something for a wedding, they're not asking for their own wedding dress, they're asking for something to be a bridesmaid at, or they're asking for something to wear in the crowd at a wedding. So in that case, you know, these different lacy dresses that have like sort of light, happy, summery patterns to them are probably pretty good. Same thing as at Stitch Fix, we don't carry Nike, but when clients ask for Nike, we can send them different types of sneakers. We can send them sportsy long sleeve jackets. We send them leggings, which are really great for running and every other context actually. The top matches for words when clients say that they want something bright is going to be very, very bright clothes, very high contrast patterns. And like I said, we've actually been making it possible to find the meanings of items, right? Which means that if items and words exist in the same space, then you can actually use the items as query terms. So let's say that you've been on Amazon before probably and bought a toaster. And sometimes Amazon will say, oh, well, here are a whole bunch of other toasters that you might like, even if you've already bought a toaster. So this particular problem is partly because they have some representation of these items. They know how similar these two things are. So if you're looking at a particular dress, maybe it's not the right one for a client, right? But like there are some others that are. We can say this floral dress here is actually really similar to these other dresses. Maybe consider these as an alternative. Like I said, these representations that we learn are flexible. So a search for the term ivory, which is sort of an off-white, sort of warm yellow, kind of white color, will give us mostly white things with this new way, but with the classic sort of information retrieval approach, we'll end up learning a lot of sort of yellow things. And from sort of like taking a broad step back, the things that we learn make sort of sense like from a business perspective. So it turns out that our men's clients actually talk about what they want in a totally different way from how our women's clients do. So our inventory is fairly different for men's. It's mostly plaid shirts, khaki pants, things like that. Because men's clothing, it turns out, has lower variance than women's clothing, at least in terms of like what our clients seem to want. Men's inventory ends up in a totally different space from our women's inventory. So what we actually end up seeing are that tops for women's are sort of similar to tops for men's, but they're actually still inhabiting almost completely different axes in this vector space, which is not something that you would notice if you were just doing classic information retrieval approaches to this problem. And so this is kind of zooming in on those general clusters. So what you see on the far left are a bunch of cardigans that are all sort of brightly colored, some of which are like just different colors of the same kind of cardigan. In the middle, you see a short sleeve or not very long sleeve, bright colored tops that are all sort of loose, because you can tell by like all the extra hanging fabric. And on the far right, you can see that there are a whole bunch of men's shirts, which appear to be stripes, and most of which have long sleeves. So we're able to learn just from like word co-occurrences that these items are similar to each other in this vector space. So I'm going to kind of like walk you through some of the general like kind of questions that we have. I don't think I have slides for these specifically, but one thing is that we want to be able to segment clients' requests into different ideas, right? So when a client says that she's looking for a black blazer and a maxi dress, we want to say, okay, those are two different ideas. So we should segment those two things and treat them as if they were two separate queries, and then maybe not allow the sort of mapping that we're learning to interfere with those two things. So I don't want to learn that a maxi dress is like a blazer. I want to learn that the clients who want maxi dresses and want blazers are similar, but not necessarily that those two things are, that the words in her request note are equally relevant to those two items. So we want to be able to segment the request into different ideas. It's clear that feedback doesn't really capture the same things as requests do, in the sense that clients will not say the same things when they are talking about an item, when they are just thinking about the items that they want. So we're using feedback in this particular case to identify alternatives. So like I was showing here, if you're considering this dress, but maybe it's not in stock, we want to be able to say, okay, well, any of these other ones is probably fine. Similarly, like we want to be able to say that these bright items are bright, but they're not necessarily going to be the things that clients are asking for. So if, for example, you're a stylist and you're responsible for writing a big long note about all the items that you're sending, maybe feedback will actually provide a bunch of like particular key terms that you can use to emphasize how different this item is from other ones. Or in the case of finding like sort of brands and things like that for stylists, even though we don't have Nike in inventory, we could still highlight it somehow in the view that they basically get to see when they're searching through inventory. Okay. Then from this data, we're actually able to build an ontology. So you can actually do sort of just simple equivalence identification. So X is a kind of Y, right? To build an idea that like this particular dress is a wedding appropriate dress, or these pants are work pants. One of the other things that I alluded to is that you can use these request notes, and you can use client feedback even to identify different client segments. So a client who talks about things in a particular way is probably different from a client who talks about things in another way. So if I'm a mom living in the middle of nowhere versus some really spendy client who lives in San Francisco, I'm probably going to be asking for different things. I'm probably going to be talking using slightly different language, and I'm almost certainly going to have a different perspective on what I want out of the service, right? So we can use language to identify these client segments, including those that we're underserving. And probably the most fun, although maybe not the like nearest business priority, is identifying trending terms. So identifying new trends in fashion is something that I think is perennially something people want to be able to do, and we have a unique data set that allows us to actually look at this. But we still have to be able to see like how servable are these requests given our sort of inventory status. So you'll have to humor me here, but like I was showing you wedding dresses earlier, you can even use the text data that clients provide us to identify when they're going to go to a wedding. So it turns out that in the United States, at least, weddings peak around sort of late May and early August. So clients are attending weddings sort of sometime in the summer and sometime at the end of summer. And this is true more or less over the entirety of the course of the business. So you'll see that the green dots and the blue dots sort of track in the exact same way. So clients are really talking about these things at the same time. Similarly, like that pink ruffle shirt that I showed you earlier, it turns out it really is trending. So in 2016, the demand for ruffles was fairly flat. In 2015, the demand for ruffles was fairly flat. But since the beginning of 2017, ruffles have become increasingly important, and so you can see that it is definitely becoming more and more popular. With some variation that I'm not entirely sure how to model, but which probably has something to do with seasonal demand. And like I said, identifying new client segments is actually fairly straightforward with methods like these. So you can predict someone's location based on where they talk about being from, but you can also predict someone's location in the same way that you can predict the items that are missing in these things. So let's say that I have all of the inventory. What things do we send most to our clients in Alaska? Well, it turns out we send them mostly flannel shirts, scarves, long sleeve shirts, things that are reasonably appropriate for the state of Alaska, which is much colder than the rest of the United States. And so, like, probably the thing that I want to drive home is that we have a lot of really interesting data, and I'm much happier to talk about, like, use cases and the lessons that we've learned here. So I think that I have 10 minutes left, and I would love to talk more about, like, what things you can actually learn from this data, and maybe, like, your own particular use cases, and the methods if you're super interested in those, which I did elide over a fair amount. Kind of in conclusion, I'm going to thank a whole bunch of people that I've been working on these problems with at Stitch Fix, some of whom have helped me develop the methods for these, which are not exactly Word2Vec, but which I'm happy to explain. Some people who have done some client segmentation using the features that I built here, as well as the people I've been building this knowledge graph with using these features. So that's the end of the slides, but I'm happy to talk more.
Hello. Thank you, Cassandra. That's great. So, real quick, if you haven't had a chance to put your questions in yet, it's Slido/crunchbp. So go ahead and get those in. We wanted to say thank you for coming to Crunch and
oh wow, that's cool.
Sharing your story with us. So
awesome.
Thank you very much.
Cool.
Let's move on to the questions. So, how do you differentiate between descriptive but vague requests like styles, like Modo, and fixed ones like sizes, 8 or small, within the unstructured data?
All right, yeah. So one thing that we definitely notice when we're doing these methods, so one thing that, okay, so talking about the methods a little bit more before I jump into this question, what Word2Vec basically gives you are things like topics, right? So each dimension in these vectors that you learn correspond to some relevant dimension in terms of what people are saying. So pretty commonly, you end up getting entire components that seem to refer to size, and you get components that seem to refer to particular kinds of entities or stylistic preferences. So the words boho or edgy will all come together in the same component, and sizes will also tend to cluster in their same component. That said, finding descriptive versus vague requests is not something that we've been able to do explicitly because we don't get unlabeled data, or we don't get labeled data. That said, we do have a bunch of labeled data for individual items. So when clients actually request exchanges, you get you get a lot of signal in terms of the ability to predict whether a client wants to exchange an item, for example. So if somebody says, like, I'm looking for this in a small, or I'm looking for this in an extra large, or I don't think a size 8 really fits me, those are really good cues that we should probably escalate this to customer service. And so typically those will end up leading to an exchange, or at the very least they tell us that clients are unhappy with the size. In terms of like whether this is something that I would like to accomplish, I would sure love to have labeled data like that. Probably the most straightforward heuristic that I would use in these particular cases is whether we're looking at what constitutes a meaningful chunk versus, say, like just an individual modifier. So if someone's asking for like a Modo jacket, that's a concept that we see a lot, right? But it only occurs in very specific contexts, so particular kinds of shipments or particular kinds of items. Whereas a size 8 is going to have a lot of diversity, right? So we have lots of things that are a size 8 or a size small. And so those will actually occur across a lot of different contexts. And so maybe we can actually leverage just some sort of information theoretic kind of approaches to this and say, well, Modo is informative and size 8 is not really. And so we can use that. It's still an unsupervised way, but potentially one that might still be elucidating.
All right, so the next question is from Jacob. How do you measure the performance of your algorithms?
We don't. I really wish that we did. So it's not actually, it's not totally clear that we have an objective to optimize in this particular case. So to the extent that I've evaluated the performance of the vectors that I'm learning, we're not really using them in any predictive way at this point in time. We're mostly just trying to see whether we're actually able to build a search engine that's relevant versus not. And when you don't have relevance data, it's a little hard to evaluate the performance. But one thing that I do spend a lot of time on is parameter tuning for the number of dimensions. And when you have a very large dimensionality, the space you end up learning is sort of nonsense, just from an intuitive perspective. And when you change the dimensionality to a level that makes sense sort of as a person, things tend to be okay. That said, once upon a time, we used to have a human computation group that we would have been able to evaluate the performance of these on. So we could say, hey, are these two items actually similar or not? And that probably would have been, sort of when that group existed, that would have been really useful.
Okay, so the next question, have you tried your application on different data sets, furniture, or on different languages? Is it possible to reach a generalization?
All right, so that one's really fun. So sometimes I get really excited about other people's data sets, and it turns out that Instacart has some data that are really similar to us. So if you don't know who Instacart are, they're basically a website that lets you add things from a grocery store or like a restaurant to your cart, and then that'll be delivered to your house. So you can add a whole bunch of different things that maybe fall into the category of like a recipe. So you want tomato sauce, and you want cheese, and you want pasta. So I've used this algorithm on Instacart data before, and it actually performs reasonably well. So you'll learn that different kinds of cans of tomatoes, for example, are similar to each other. You also learn that like different vegetables, which don't necessarily go in the same recipe, but which tend to occupy the same kinds of spaces in different recipes. So like zucchini and like regular squash tend to sort of cluster together. So you learn that those two things are very similar. And I think that as far as this particular algorithm goes, that it generalizes to like a very wide context. So I obviously don't think that it applies to all contexts, but if you're interested in clusters in a very, like that originate from a very high dimensional space, and you want to narrow that down, the algorithm we use is actually very flexible. As long as the values you're using are discrete and categorical, rather than like trying to predict like time series analysis.
Okay, well we're about at time right now, so if we didn't get to your question, I think Cassandra's going to be around. And I imagine she'd be grateful if you pulled her aside and asked those questions. Thank you so much. It was a great story. Please welcome, thank Cassandra.